Hello, good day, everyone. We are live again. We should be live on all of the major broadcast live stream networks, Twitch and YouTube and X and LinkedIn. So if you are watching us, please would love to have you send us a comment, reach out to us. We're always happy to hear from you. So today I want to talk about event-driven applications or event-driven architecture. You build event-driven applications on event-driven architecture, I guess. But the idea behind that is essentially we're going to be sending events through the system, choreographing those events, and using asynchronous processing in order to react to those events. So I have been planning a lot of things for these live streams, and we never get through all of them. So I haven't planned a lot for today, hoping that we can get through all of it and maybe leave some time for questions if we have some questions. Anyway, so I'm Jeremy Daly. I'm the CEO and one of the founders here at Ampt. If you're not familiar with Ampt, Ampt is a service that allows you to just write application code. And we take that application code, we analyze that application code, we figure out exactly how exactly which resources you need, things like that, and then we deploy that directly to AWS on your behalf. We manage all those patterns for you, we manage all those interactions for you, so you get the full scalability of the cloud. But you don't have to worry about managing all those intricacies of it, and you don't have to be responsible for optimizing all those things. We do all that for you as well. So anyways, if you can tell, I do have a bit of a cold, so I will cough a little bit, but the show must go on, so we will get through that. Sebastian is here. Hey, Sebastian, thanks for joining the broadcast. We appreciate it. Okay, so let's get into EDAs. So one of the best places you can find out about event-driven architectures or event-driven applications is the AWS Serverless Land website. They have a whole section here called EDAs. Lots of valuable information in here, including the EDA guide. David Boyne does these EDA visualizations that are very, very cool that sort of show you, what these different patterns are and things like that. And then give you some more information about like who's actually building these things, which are a lot of people because EDAs have become extremely popular. If you're familiar with some of the events that have been going on lately, there are these events called EDA days that AWS has been doing. But it is a very, very powerful. Technique or a powerful pattern or powerful patterns that you can use to do quite a bit of stuff and allow you to scale. Scale is one of the big things here, where it's sort of like with these event-driven architectures, we can do small bits of work, capture that work, and then distribute that work to other systems that allows us to do some interesting things with it. So just maybe give a definition of what EDAs are. So event-driven architectures are an architectural style that uses events and asynchronous communication to loosely couple an application's components. Event-driven architectures can help you boost agility and build reliable, scalable applications. And when you are using AWS directly, services like Amazon Event Bridge are extremely important because that is that centralized event bus that allows you to connect into all kinds of different AWS services, which is really, really great. Step functions allows you to do instead of doing choreography, you're doing orchestration. So this keeps the state between those different events as opposed to sort of fire and forget. And then Amazon SQS and SNS are just ways to send messages between different services, queuing and topics. And then Lambda obviously is great for doing the processing of it. Okay, so enough about what EDAs are. Let's go ahead and jump into some code, and we'll start looking at some stuff here. So I just started I'll exit out of this quickly. So I just created a project in Ampt. Again, to create a project in Ampt, you just need the Ampt CLI. That is a pretty simple thing to set up. You come here to the docs, you install the CLI here. It's behind my head. Move this way. You install the CLI and that's it. You run the CLI. You run Ampt and you connect in. You'll have to authorize your account and sign in, but that's all fairly easy to do. But essentially, I've created this app here That's just a simple Hono app. I know I've been using Hono all the time. Huge fan of this. It is just such a nice framework to work with, and works great with TypeScript and these other things that it's got integrated with it. So, anyways, big fan of Hono. So, but Hono is essentially just something like Express or Fastify or one of these, but it's a web standards framework, so it uses the fetch event. So this app Fire here actually creates an add event listener that listens for fetch events, which connects with the Ampt layer that we install for our runtime that allows you to follow these web standards and use those things. So essentially, all we've done here is just create an app called the Hono app, or initialized a Hono app, and then we have a route called hello that just fires back some text for us that says hello. So if I open this here and just make sure that we target the right browser, so if I open up this, and we're going to get the static page here. Again, I know I mention this all the time, but the way that Ampt works is we give you this default static folder. Anything you put in the static folder will just render as a static asset for you. And these can run side by side with your dynamic routes. So that dynamic route we called hello. I run that there and we spit back hello. And again, the way that Ampt works is you are running this code, you are editing this code locally. This is all local. Anything you want to run here, we can use our Copilot, we can use linters, we can use Prettier, we can use whatever we want to run locally within our IDE, we can do that. And then every time we make a change, that is synced to the cloud. So if I say hello from Ampt here with an exclamation point, I haven't saved this yet. So not saved. See this little thunderbolt down here. The second I hit save, that's going to spin and say that it's been synced. I go over here, I refresh, and hello from Ampt. Now, this is running in the cloud. This is a cloud sandbox dedicated to you. High fidelity sandbox, has all of the same powers as your production would have. So we'll be working in this just for development. This is the typical workflow here. So let's play around with some things and figure out what we want to do here for some EDA stuff. So, all right. So first of all, a big thing about EDA is either generating events or capturing events. So having an event to pass around is an important thing. So one of the patterns that I really, really like is this idea of what's called storage first. Eric Johnson from AWS talks about this quite a bit as well. And the idea here is to say that when an event comes into your system, right, and this event may come in from anywhere. This could come from a webhook. This might come from some other producer or whatever it is. But the point is an event comes into your system and your application, whether that's a microservice or it's a monolith or it doesn't matter, that receives that event. And you want to be able to capture that event so that you can do some processing. So a big mistake, I don't know if it's a big mistake, but a mistake that I think some people make is they'll get an event in, and then when they get that event, in that same process that they receive that event, they try to do a significant amount of processing on it. So for example, maybe it's an event that says, new user signed up, and I want to send an email address, or I want to send an email when a new user signs up. So let's say that event comes in, and then we immediately try to connect to SendGrid or Resend or one of these other, Blue something, whatever. I don't know why my Elgato is that what it's called? Elgato is being flaky. But anyways, so that event comes in, and we want to send that email address. We try to connect to Resend. We try to connect to SendGrid or whatever it is. Now let's say that fails for whatever reason. Maybe there's a bad email address, and okay, fine, we would want to fail that in the first place. But maybe there's something else that goes on. Maybe SendGrid is down. Maybe there's some issue with a character in there or something like that. The problem is that if we try to process that at that point, then it potentially could fail the entire sort of request, and then that event that we got, we probably just lost that event. So it's always a good idea to try to capture the event first and then write your code to process it after the fact. So there's a number of different ways to do this. I'm a big fan of sticking things in something like SQS, depending on the volume, right? If you're not necessarily writing things to the database, or you don't necessarily need something hardened in the database right away, again, depending on the type of event, having that come in through SQS or saving that in SQS and then processing that later is super helpful. But there are many times where you want to just make sure you capture the event itself, and you have a record of that event, and then you want to go ahead and process off of that event later. So here's what we're going to do. We're going to do the storage first pattern, and I'm going to show you this and how we can do this, accomplish this using Ampt and our infrastructure from code, and how this is going to work. And then we'll show a couple of different ways that we can deal with errors and a couple of other things like that. So the first thing we're going to do is we need to be able to capture an event. And so we'll just use a standard webhook to capture events to start here. So what I'm going to do is I'm going to create a new route, and I'm going to call this app.post. So this will be a post route. We do not want to call it hello, but that's okay. We'll fix this here. So let's just call this event. All right. So this will be a post that we post to event. It'll be just our URL/event, and we'll receive an event, and then we'll do something with that event. All right. So for now, all we want to do is simply, just make sure that the route works. So let's, we'll return a JSON that says the event was received. What we actually want to do is we want to process that. So let's do const, and we'll say event equals, and there's some handy things here where we just say rec.json, I believe. I think that's the right way to do that. Let me make this a little bit smaller so we can see. Okay, so what this should do is this should take the and I'm going to actually change this to body just so that we can do that. And so this is going to grab the body, which was assuming is going to be JSON, and then it's going to say message received. And let's go ahead and just spit back the body so that we can see it as well. All right, so we've got our URL here. All right, we can't post in our browser here, so what we'll do is we'll just use, let's use Postman here. All right, so we've got our URL. We'll copy this like this. And we'll create a new post here that'll go to this. And I don't know if this is too small to see, so I'll zoom in a little bit. So this, and we are posting to the endpoint. We called it event. And then what we want to make sure we do is we want to send in a body. That body is going to be just raw JSON. And we'll just pass in, let's see, name, Jane Doe, and we'll say age is 30, like that. Okay, so we'll go ahead and send that event. And what this should do is this should say that the message was received and the body is blank. So clearly we did something wrong there. Let me let's see, go back over to our code. So what do we do? So this is probably wrong. So what we do when we don't get something right is we just jump over to the documentation. I've been using Hono for a while now, but I'm still getting used to it. So just JSON. Oh, it's just crec. Oh, await. Are we not awaiting it? That's why. We need to await this, which means we need to make this async. Okay. All right, so that should work now. All right, so we'll clear this and come back over to here, refresh. I don't know why I hit refresh, just in my brain. Okay, there we go. All right, so we now have this request coming in. Jane Doe, body is the name, and the age. Perfect. Okay, so a couple different things. Oftentimes when we do these hello world type things, we skip validation because it's like, oh, you can validate later. I'm guilty of this myself because sometimes it takes a while to do validation, but we shouldn't skip validation. Validation is super important with events, right? And we always skip this, so I think it's important that we do something with validation. I like Zod. If you haven't used Zod, Zod is a very, very cool, not sod, that's grass. Zod is a very, very cool TypeScript first validation, schema validation with static type inference. Very, very cool. It gets a little complicated, but if you're using TypeScript and you want to export types, you can infer types from it. It's very, very cool. Anyways, big fan of this. Okay, so we installed Zod over here, and then we can just go ahead and import Z from Zod like that. So now we have the Z command that we can use to actually build schemas. So we'll build a schema called const. Let's call this event schema, and we'll make this an object, and this is already filling in stuff for us. So this is saying that the name has to be a string and the age has to be a number. Now, some cool things we can do with this, by the way, if we look at like numbers, we can actually set all kinds of constraints on those, right? So we could go in here and say that this number has to be greater than or equal to, let's say you got to be at least 18 here, and then it's got to be less than or equal to 100. That seems kind of old. Well, we're not going to be ageist here. All right. So anyway, so we could say this. We could also do with strings, for example. If I can find this here, string. Probably search would be better. Strings. Okay, so strings you can set like a length or a min max, right? So we can go ahead and say that we want this to be max of, I'm going to say it, well, this way we can, well, I'll do 30 for now, but we'll adjust that later. So essentially what we've done is we've created an event schema. If we did want to have, we could do this, we could do, and actually we can have a type. How do we do this? I'm trying to remember. It's, I think you do what? Const type event schema equals z infer, something like this. Infer does not exist on type of event schema. Okay. I know there's some way to do this. Or do you just do type? I don't know. I'm not great at TypeScript. Okay, that should be it, like this. Yeah, okay, there we go. Is declare but never use. Okay, so we declare a type, we can infer it from this, and then we could make sure if we're generating an event, we can make sure that it meets this particular schema when we're generating it. So if we wanted it for our types, we don't need that to validate it. This will do that for us, but we do have the option to do the type here, and I'm pretty sure this is right. I'm going to look, though, because I want to make sure that I get it right. Let's see, f type. Let me do infer, because that'll tell me what I need. Type inference. I think that's right. Infer type of, yeah, so type, yeah, okay, that's what we want to do. Anyway, so that's cool. It's just a helpful way that you can infer those types, and then that way you can make sure that it matches those types. I don't think any of this stuff works with that, though, but at least this stuff does. Okay, so anyway, so now we want to validate that type. So now we get this body in, and then what we can do is we can say result, it's doing it for us, event schema, and it does a safe parse of the body. There's two different ways that you can parse in Zog. So one is parse, which will fail if there's an error, and then there's a safe parse. By the way, with Hono, another thing that Hono has, you're more than welcome to jump into this if you want to. They have some things here on validation, and so you have this validator that you can bring in. You can validate with Zod if you want to. So right here in the header is like a middleware. You can validate the type of input against their schema and so forth, or you can use this Zod validator middleware that will fail if it doesn't pass the validation for you here. So that's all fine and good. You can do that. I want to keep it a little bit simple here and just sort of see these results. So so let's go to let's do this. So let's just go ahead and log out. We'll log out the result here. And then the interesting thing, too, is that the way that result works is result will spit out. I'm just going to show you. I'll make it easier here. How about we do that? All right, so let's go ahead and send this again. So this was received, and then we should get this log that says success is true, and the data is name, Jane Doe, age is 30. Now, if for some reason we were to go over to here, and let's say we sent the age in as a string instead, and we hit send, then what this should do is this should say success false. So this is telling us that it didn't pass the validation. So now we can use this, and we can say if result success, don't need that, then we can go ahead and we'll return this, and then rather than, we'll do result dot data, so we can see the parse. Yeah, result.data, that should be right. Why is it angry at me? Result, save parse success. Oh, maybe it's just angry because I don't have a closing thing yet. Otherwise, should be result.data, right? Result.data. Why is that not? Oh, how about I do this? Just don't know how to program in JavaScript anymore, I guess. Otherwise, we want to return a message. So we can say, all right, invalid event, that's fine. And then if we want, we can return, I think 400 is probably the right one to return here. So now if we go over here and we hit send, we'll get invalid event with a 400 bad request. The request cannot be fulfilled due to bad syntax. That's correct because we in fact sent in an invalid number. So if we do 30 again like this, close that out and send, then we should get that it's true, everything looks good, event received. And now we set some numbers here, right? So if we set this to 10 and I hit send, it's going to tell it's a bad request because now it's validating that stuff for us. So this is just super helpful because, again, we don't want people sending junk into our events. We want the schemas to match. There are ways you can do optional in this here. So for example, if we wanted to add another field and we wanted to say, I don't know, we'll call it state, this will be a z.string with a length .2, and this can be optional like that. And so what should happen is now when we go ahead, so this is a string length 2, but it's optional. So if we go and try to pass this in again, and we'll set this as 30, we hit send, this will be just fine. If we want to send in our state like this, and we send in MA, if we send this, this will validate just fine. If we send in MASS for mass, if we send this, this will be invalid. So it's just a really great way, and very simple and very portable, and again, very type friendly. So if you are a big TypeScript person and you want to use these types, it's just a great way to create these schemas, and you can use it to validate against all different types of things. So, all right, anyway, so let's go ahead. I'm going to remove this here because we don't want that. We'll just double check, make sure that works. Okay, good. So we've got our event, we've got our end hook, our webhook set up. We are parsing and validating the body that is being sent to our webhook, and now we need to capture it, right? So this is where we want to do that storage first pattern. So the first thing we're going to do is we're going to do it with data. So first thing we need to do is make sure that we install at ampt/data. If you're not familiar with data, we did a couple live streams on this. You can go back and take a look at those. Data is very, very powerful abstraction on top of AWS or Amazon DynamoDB. So we try to make it super easy in terms of just getting and setting data. Those are the primary things. And then we automatically build in the ability for you to respond to changes. I think I can see if I can zoom here. Oh, there we go. So you can automatically respond to, I don't know why this is not, oh, there we go. Okay. Yeah, sorry. Where was I? Reacting to data changes. Here we go. So yeah, so you can define these data handlers. You can listen to these data handlers. So it is very, very cool stuff that you can do. Okay. So anyways, so we've imported our data here. Which means, I'm sorry, we installed data, which means we need to import the data handler like this, and it is called lowercase data. That's fine, it's close enough. And then what we want to do is we actually want to write this event to the database so that we can capture it. So assuming that it is successful, because if it's not successful, if it doesn't meet our validation standards, then we want to just throw that event away. So what we do is we're going to do const, and we'll say, we already used result, so let's use, let's see. I usually use result, but let's call it event. Why not? All right, so we want to do, await data.set like this. And the way the data.set works is it takes some sort of a key, so some sort of name, what we want to name the event, what we want to name the record, the item, and then whatever data we want to pass in. So we're going to call this, let's do event, and then we'll use a pound symbol here, and we're going to put something after this in a second, and then we're going to save the result.data. So we want to distinguish these events. These are unique events. We don't have an identifier that is coming in from our webhook that would allow us to make a event unique. we also, we also don't want somebody to maybe manipulate that. So we want to make sure we always create something unique. So I like ULIDs. You can use UUIDs. A ULID doesn't really matter here, honestly, because we're not sorting on it. We could sort on it. There's different ways we can do it, but we just need some sort of an identifier. So I'm going to install the ULID package. Again, it could be UUID. That's perfectly fine. And then we're just going to import ULID here from ULID like that. And then in here, when we generate the event, we're just going to generate the event name. And in here, we'll create a ULID like that. Okay, so I'm using a pound symbol here just as a delimiter. If you use the colon with Ampt data, that creates a collection. So we don't want to do that. We want this just to be an individual record. There's a million different ways to do data design. This is for the purpose of this. We just want to capture this as an independent item that's not part of a collection, just accessible by its ID. And so what we do here is we're just creating this random ID, but we're going to use this pound. This is going to come in important later because we're going to use that in order to listen for changes in the data so that we can actually react to it. All right, so we're going to set this data. We're going to set the result to data there. And then I'm just going to call this DB underscore result. How about that? DB result. And then I'm going to say message received. And for result here, I'm going to actually spit back the DB result so that we see what that looks like. Okay, so assuming everything has gone to plan here, we go back to this, we send this again, and we now have the result as the name and the age. And if we go back to our code, we didn't log anything out there, so we can actually look, though, if we want to. We can type in open here, or dashboard, either one. It'll bring us into our dashboard. And we'll go into the data here. We'll get all items, and we will see that we now have this event. Go into the event, we see it's Jane Doe, and the age is 30, and we get this event, a pound, and some information about it. Okay, so there are labels, there are other things that we can use that will allow us to query this data after the fact. This is DynamoDB, so this is a NoSQL database, right? So that unless you have the key in order to access it, or you run a scan, or you have some other way, you have it in a label or a GSI or something like that to access it, this is just going to write the data and it's sort of done. So there's not much information. So this is written and it's sort of gone. And I guess that's my point, right? So we've written this event and we've captured this event, and nothing has happened with it. We've done no other processing. It's just here. All right. What we want to be able to do, though, is we want to be able to process. We want to be able to do something when this event comes in, or when this data is saved. So what we can do is we can create a data.on. All right, and then you specify what type of action is happening. So you can either look at every type of action, or you can only respond when data is created, deleted, or updated. So in this case, we only care about the first time the data is written. That's when we want to actually do something. So we're going to go ahead and put created here, but then what we can do is we can put a colon and then actually specify some detail about just sort of a glob pattern to decide how we, which events or which named items we want to actually process. So here I'm going to do, we have event, and I'm going to do pound, and then I'm going to do star, so that sort of that wild card after it. And then this is going to come in, and this is naming itself event. I guess we can keep that. That's fine. So now we should get an event, or this is, I'm going to call this, I don't want to confuse events and records. So I'm going to call this item, and then we're just going to go ahead and log new record. I should use DynamoDB terms. New item. How about that? And then the item. Okay. So we've already got this item stored here, right? We're generating a unique ID for it. So if we get the same event over and over again, it's gonna generate a unique ID every time. We don't have time to talk about idempotency. One of the things we could do is we could certainly take the record itself and we could hash it and use that as an idempotency key or something like that. We're not going to do that now, so we'll that's a little bit more advanced. But what we can we'll get into some of the more interesting things we can do once we receive the events. Okay, so the event comes in here. Right? We get that. We set this, so we've captured the event. We've done no other processing other than to make sure that we've captured the event. Now, one of the things that we can do, just again to sort of nail this point home, is if this fails because it can't write it to the database, we're not capturing that right now. That is something that we could do. So we could write a try catch here and fail, and then hopefully the producer would say, oh, I tried to post to this webhook, it didn't work, I need to post it again. Certainly if it's an invalid event, if it's not a well-formed event, then it's going to reject it, and I don't know what the producer might do in that case if it's a 400, but if it was something where it was a 500 or some other failure where it said, oh, I got to keep trying this, it was a retriable event, it could do that. So anyways, we haven't written that logic in, but you can see, again, if this is, we can do a try catch here and fail back to the producer if we wanted to. Okay, so once that's written, though, now, again, we're listening for it. We want to process something. So let's just verify that this works here. So we're going to go over to our, back to Postman, and we're going to post another event here, and let's change her age to 31. We'll click send. This was received, and then what we should get here is we'll get this information that pops up that says, okay, here's our new item. Zoom in a little bit. Hide this. So here's our new item. Here's the key, right? So that's that event pound, right? And it's only responding to those event pounds when we create those new items. Here's this ULID that we can use if we need to sort or something in the future, which again, we're not going to use that right now. And then here's the value. So we get the name, we get the age, and then we get to create in a modified date. Notice that this previous is the previous is undefined, and that's because there are no, because this is a new record that's created. If this event was to get updated and we were listening for an updated event, then we would get some other information. Let's see, Doug says here, Doug popped on in a non-durable manner, which is sometimes useful. I'm not sure what that's in reference to, but it is sometimes. I mean, I guess if I'm thinking about this, then maybe it has something to do with sometimes you don't want the events to be durable, which is true. Sometimes you do want the events to be thrown away. But I don't know. Maybe Doug, comment again with some more context around that. Anyway, so we've captured this event, and now we get an action that pops up, or we get a handler that can respond to something happening here. So the reason why this is important, oops, what did I just do? Sorry, trying to get back to my normal size here. So the reason why this is important that we capture this separately is this is happening asynchronously, okay? So if for some reason this was to fail, if there was an issue here, right? So now we want to, send a text message with Twilio. We want to send send something with resend. We want to write something to some other database somewhere else. We want to enrich this by, reaching out to another API and pulling down a bunch of data. Whatever it is that we want to do, there's a million reasons why those things can fail, right? And so what happens if that fails? All right, so here's what I'm going to do. I'm going to go ahead and intentionally throw an error in here, and I'm just going to say, spell it right, throw, can't spell. Okay, I'm going to just throw and say, this is an error. All right, and I probably should be wrapping it in a new error constructor. But anyway, so I'm going to do this. I'm going to just say this is an error. All right, now I'm going to go back to Postman, and this time John Doe is going to sign up like this, and I'm going to send this request. Okay, so error. We're getting these errors. Okay, that's because it's trying to process this event, but it keeps getting this error, getting this error. Now, the good news is that somewhere over here, if we go back to our we see that we get this John Doe. So John Doe, we've captured this information, all right? But over here in our application, we're still getting these errors. Now, here's the good news. If I go in here and fix this error or something, again, let's say the error stops. So now the SendGrid is finally responding or whatever it is. I'm going to save this. All right, and I'm going to wait a little bit, and this is going to keep retrying that thing. It uses an exponential back off. I might be outside the window now, so it might take a little bit of time for this to actually work. But now that this is, so there we go. So now it reprocessed that event for me, and this time it worked. Okay, so there's a couple different reasons why this is, again, super important. If you have a downstream system or some other piece of your application that needs to be doing something and that fails for any reason, again, network connectivity issues, they're in maintenance mode or whatever they're doing, having the ability to capture the event and ensure that we have that data and then be able to do something with it is incredibly powerful. Okay. So we're not going to go into the details of exactly how you would then process it or what you're going to do, but some of the things you could do here as well is you could actually go and just update the data. So maybe let me just show a quick example of that. So for example, let's say that this comes down, the item comes down, and we want to do something with this item. We could just go ahead and await. We'll have to add an async here. So we could await this, and we could do data.set. And we know that we can grab the key from the item.key like this. So we know that what we want to update. And then we just want to say processed is true, something like that. Item.key, what's this telling me? Key does not exist on type previous, because it's item.key. Okay. All right, so we could do something like this if we wanted to. And again, if we want to, I can even log this out like that. So we'll see the new item, and then we'll see what happens when it updates it to true. Now, the great thing about this is we are not going to, because here we're listening for created, right? We're not listening for updated. We don't have to worry about the updated piece of this. We don't have to worry about this event firing over and over again and giving us giving us some sort of a loop. So let's go in here and let's change John's age to 35, and we'll go ahead and hit send. So this will go ahead and process this event. Right, and then it's going to go ahead and do a data change capture as well, and tell us that process is true, and that John. So this is this is spitting back this right here. So John Doe, age 35. Now this only fired once, right? Because it just did this, and then it updated. It didn't keep triggering over and over again. And if we go back to the record here. For John Doe, for the new one we just created at 35, now we see that this process is true. So we can update the data in any way that we want to, which we can then use to even process something else. I mean, so we could listen for different types of events, like a data change event. So when John's record gets changed, then we want to do something else based off of that. So again, that's one way to do it. So I like this pattern a lot. It's a very effective pattern for really hardening the data and making sure that we have stuff there, or that we don't lose events. Okay, but this is event-driven. Yes, this is an event-driven sort of mechanism. Maybe it's change data capture. Maybe if we want to think about it that way. Maybe not what everybody thinks traditionally of as sort of events and sending events around. I can see that. Okay, so let's do this. Let's make sure that we have the SDK installed. So install at ampt/SDK like that, and we're going to bring in the events import, and we're going to bring in the events interface, not from Ampt events, from the SDK. Okay, so what events do in Ampt, let me go over to our events here. So the events interface that we have, essentially the idea here is to allow you to build event-driven workflows using same idea that you capture the event, but you can send these events. They're a little bit more lightweight, right? So we're not writing them to a database, and that really is discretion that's just sort of up to you in terms of how important the events are. Now, again, these events are durable in the sense that they will last for quite some time. If you look at, let's see, if we go into the detail here, what does it say? So events, I believe, are kept for 24 hours. if I can find the information here for you. Discarding events. How about that? Okay, so discard events. All right, so I know it's every 6 hours, right? So default handlers finished with, no, that's that. Where's my, good thing I can read this stuff here. Okay, so all right, actually, this is really, if you go and read the docs, there's some really interesting things you can do here, including the number of times you've received an event. Like, all that information is actually sent with an event, which is really, really handy. And so yeah, so if any of your handlers throws an error, processing is considered to have failed. Failed events are retried every 6 minutes for up to 14 days. So that's this right here, right? And so this is important because the 14 days, obviously is a long time. We set that limit, I think, just to make sure that you've got plenty of time for downstream systems to figure things out. These are not ordered events. Also, I mean, one thing about the data events is that those data events are ordered. So those will always come in the same order. And one of the things about that is that if you're getting an event blocked because of an error, that'll block all the events after that, right? So it sort of guarantees that order of processing for you. The way that these events work is that they're not ordered, so you can pass over certain events and other events will come in and so forth. It won't block all the event processing for you. Okay, so let's just jump into this and then we can see sort of how this works. So so we've got this events here. So now we still want to process our event schema. We still want to make sure we validate it. Everything's good to go. But rather than us sending this to the database now, we're going to publish an event instead. So I'll do const and I'll say, how about EVT results like this. And we're going to await, and this is events.publish, events result data, and then we need to name this event. So events have to have a name. You have to be listening for a particular name or type of event. So let's call this webhook dot received, I before E except after C, and this is called EV result. I can go ahead and hide this, we don't need that. So this is our EVT result, and we'll pass our result here as our EVT result like that. Okay, we don't have a listener for it, but we are processing this event and we should see what this returns to us. So if we jump back over to our webhook and let's just, for the heck of it, John keeps getting older, and we will send. So this is the information that we get back now, all right, which is a little bit different than what, obviously this isn't the data, right? We didn't write data, we didn't harden the data. Instead, we've created an event ID, the time that that event was submitted in an epoch time, and then the delay is 0 because we didn't delay it at all. So the reason why this is important is because now this event is out in the system waiting to be processed. So this is how events work, though. You have to have a listener that is listening for those events at the time that the event is sent. So essentially, if an event comes into the system, Ampt is going to process those events and say, is anyone listening for this event? If they're not, then that event will be thrown away. So what we need to do is we need to make sure that we have a handler that's listening for those events. So if we go back to our code and we create a new events.on, and then it's already filling in for us. So we're listening for this webhook.received event, and then we can go ahead and just process that. That looks good. So we're going to say event received, and it's going to spit out that event for us now. Okay, so we can sit here, we can wait. That event that we already sent, that is gone. It was processed, nobody was listening for it, and that's the way that you sort of want these systems to work when you're sending events. Events are meant to be, just, they're out there. Well, we did get that event actually. Oh, so I think that's actually one of the things that, yes, I'm sorry, I think I got that wrong. If you publish an event to the system and there are no event listeners for it, that event will essentially stay in the queue until it's processed. And then, yes, that's right. Okay, I'm sorry. I was thinking something different. But yeah, so the event will stay in the queue until it's processed. And in this case, it just got processed because we have this event listener that's listening for it. And so this event won't be processed again, though. It will, because again, we processed it and it was successful. All right. let me try this again. I'll send a new event so we can see a new event come into the system. And I'm going to change the age again just so that we know it's different. So I'll go ahead and send this. And now we get this new event. Now, usually these events come in very, very fast. There can be a slight delay on them depending on processing, but usually it's pretty much instantaneous. And then Emra, yes, Emra, thank you for... It retries every 6 minutes. It actually retries a little bit faster than that initially, I noticed. So it's supposed to be a retry every 6 minutes, but sometimes it's a little bit more aggressive. But anyway, so that wasn't a failure, though, because it successfully processed it. Let's see. Oh, Doug clarified here. So what I was trying to say on the stream, HTTP response, call, return. All right. Doug's too smart for me sometimes, so I'm not going to try to process that while I'm on the stream here. Let's get back to this. So essentially we've got our event being sent. So now we want to, again, do something with this event. So we can do anything we want with this event. We can run a bunch of processing on it. We can, again, send a message to I don't know, we send a message to SendGrid or wherever we're doing, like we can do that processing, and this is all completely disconnected from that original request. Now again, let's say we get an error. So if I throw an error here, I'll just say error like this. So if I throw an error when this event tries to process, then what we should do is I'll clear this out. Okay, and then I'll go over to my... All right, so I'm going to send an event here, all right, and then this should say application error. So it, as Emra pointed out, it takes about 6 minutes. So if there's an error, something goes wrong, it's supposed to retry in about 6 minutes or so. Sometimes a little bit faster. So we can wait for this event to reprocess. And I do kind of, I'm going to leave this in the background because I want to show you some interesting things about how the attempts automatically increases, and you can use that information to do some interesting things. So actually, while that's doing that in the background, let's talk about some of the ways in which this actually works. Zoom in a little bit here. Okay, so this is the idea of handling events with the dot on. Make sure it's not behind me, but I want to make sure we can also see the other side there. Okay, so when you get this event, you get a couple of bits of information that come into it. So you saw the ID, we see the name, the body, the time, the delay, and the number of times that the event has been attempted. There's also a context object that that you can pass through as the second parameter, the second argument in your receiving in your handler. And then what you can actually do is, by default, we set a timeout. These handlers only run for so long, but if you need them to run for longer, you can either set them to run for longer in the actual code when you define the handler itself. So you can do a set timeout up here. Let's see if I can find this. Maybe it's down here. Yeah, so you can set the timeout like this as a second argument when you create your handler, and then but then in your actual function handler, you can have a second argument there that receives the context object. And when you receive that context object, then what you can actually do is set a timeout in there so you can actually change it based off of the event you get. So if for some reason it's an event that has some semantics in it, and dynamically you say, oh, this is going to take longer to process because it's a different type of event or whatever it is, then you can go ahead and you can do that, and it will change the timeout just specifically for that particular execution. So pretty handy there. So then some of the other things that hopefully this will reprocess in a few seconds here. I guess it's, if it takes 6 minutes, we've got a few more minutes. So so this is what's interesting though about the way that some of this stuff works is, so you get this request and you've published it and so forth, blah, blah, blah. Now it comes in, and now you have a couple different options. If you want to say, all right, this event is successful, we've done what we need to do, all you need to do is return from that handler successfully. So even if there's an error, so even if something fails somewhere along the lines, you can just go ahead and return, capture that error or catch that error, and then go ahead and return, from the function without an error, and then it will process it and say this event is gone. if you throw an error from it, like we just did, it will go ahead and try to reprocess that event over and over again until the actual, until it actually can process. So what you can do with this, though, which is pretty cool, is if you did want to keep trying an event for a certain amount of time, but then after, maybe 10 attempts, you say, okay, after 10 attempts or after 3 attempts, I want it gone. Then that's all you have to do is you simply say, look, you catch the error, and then you check to see the semantics of the event that came in, and you say, okay, so this has been tried 3 times. I'm going to go ahead and I'm going to just return successfully from this. Now, here's the other cool thing that you can do, is that you can use things like, again, the time and all this information to say, once the event is older than 3 hours, then let's throw the event out. But if you say, I want to capture that event because, I want to sort of like, we use a sort of an internal way of managing like dead letter queues and some of that stuff. But if you wanted to go ahead and say, I want to capture this event and I want to save it so that I can inspect it later, then right from there, from your catch, you just go ahead and write that to data, and say, this was an error, this failed for some reason. But then you can return a valid or return true or whatever from the handler, and then that way it will clear the event from the system, so it won't keep trying to process that event. But what's cool about that is now you have this you have this hardened somewhere else that you can go ahead and use that to inspect. And then replay those events if you wanted to, using some sort of custom replay, which again could just search for failed events, and then you can inspect them, you can replay them, you can manage them. So there's a bunch of cool things you can do there. All right, so it is 11:50. And this says 11:45:53. So we should be getting close to this firing off again. Trying to think of anything else that I can talk about for a few more minutes before we get into that. So, discarding the event. We talked about this. The timeouts there. So there's a bunch of other things, by the way. Is that one of the things that we try to do with Ampt is basically make it pretty much entirely event driven. So if we go into the docs, and let me make this a little bit bigger so we can see over here, most of our interfaces are really meant to be event driven, at least or give you that event driven feel when you need those things. So tasks is something where sort of you fire off an asynchronous event, or you fire off an event that starts a task process that runs in the background, right? So tasks are great where you have to do a lot of work behind the scenes, that you can go ahead and you can fire that off. We just got this in. So now you can see that we got attempt number 2, and the application error, because we're still firing an error there, and so this was roughly 6 minutes after the first attempt. So what we don't want that to keep throwing errors, so I'm going to get rid of that there. So the next time that comes through, that's going to process. So just quickly back to some of the stuff here. So again, tasks are for long-running tasks, I guess, for long-running jobs. So it's great that if you get so let's say you use events for capturing that initial request, and then that fires off in the background. That has to do a little bit of work. Maybe it's like, oh, I got to check something, but then I got to send it into like a long running task. Like it's perfect for that. Same thing with when you write something to a database. When that database captures the data, then you can wait for the change data capture to fire, and then you can use that to fire off a task to do some processing behind the scenes, and of course that keeps all the state and interesting stuff like that. Events have a .on, so you can listen for the .on event for anytime something happens there. Storage also has a .on event, and so you can go, let's see if we can find here, listeners. So you can do a storage.on. So if you write something, if you delete something, you can, if something gets changed in your storage buckets, you can write an event that responds to that. So if you want to generate thumbnails when somebody uploads an image, or you want to email a PDF when somebody does something, or whatever you want to do, you have the ability to do that. And then we showed you the data.on as well, where you can kind of process that. So All right, so we're getting close to the end of the time here. I think I covered most of what I wanted to cover, so that's good. But yeah, so just sort of a recap here. When you're building event-driven applications, the idea is to essentially capture the event, process the event as efficiently and as quickly as possible, and then harden that some way, give it some durability so that you can actually do more work behind the scenes. Eric Johnson jokes about this all the time, where he says, the most dangerous code is the code that you as a developer write, right? So the as much of that stuff that you can hand off to the system that says, okay, here's the event. The event is coming. I want to take that event and I want to make sure that I capture that event. I don't want to lose that event, because there's a good chance that my producer, whether that is somebody who clicks a button on a website or a webhook that comes through from some other third-party system, or a Stripe webhook comes through, or whatever it is, there's a good chance that event is never going to get sent to me again. And if I lose the event at the time when I have the chance to process it, that's really, really bad. So hardening that event in a way that then gives me the capability to process after the fact, and do more work after the fact is a really, really powerful pattern that is very useful to have. So we try to make it super simple with Ampt. Again, we have very simple primitives for this idea of events. We have data that gives you access to DynamoDB and then automatically build your DynamoDB streams off the back end of those, just using data.on. So hopefully, that makes it super simple to build these sort of workflows. And then again, if you have something really complex, if you need to build like a state machine, you've got multiple steps and so forth, tasks are a great way to do that right now. You can build really, really complex workflows in there. And then the other thing that's great about tasks is from within tasks, you can send events, you can write data, you can do all these other things, and then you can process, the changes and listen for different changes and different events that happen there through that. So, so I think that's about it. I think we kept it to an hour, which is good. I would encourage you to go ahead and check out Ampt. It's very easy to use. Again, the goal here is to make it to handle most of that complex heavy lifting, all that cruft, all the stuff that as developers, I'm a developer. I was sort of forced to become a cloud architect because I was building in AWS, and as a developer, I needed to learn all this stuff. I think it's super helpful to understand the concepts behind distributed systems, understand this idea of eventual consistency. I mean, one thing to remember is when you fire off an event, or even when you write something to the database and then you're listening for that capture, you're listening for the change data capture, that there's a delay there, right? There is going to be some bit of a delay. So if your goal is to say, hey, I want to capture this event and then I want to send them an email, I want to update some system, I want to increment, their member points, I want to do whatever I have to do. Remember that some of that stuff is going to take time. Generally, it's very, very fast, but eventual consistency means that it will eventually be consistent, and that model will eventually get there. There's also the possibility that you've got an event that gets fired off, you've got 5 or 6 different things that are listening for the same exact event. Maybe you've got a sales system, you've got a loyalty system, you've got a billing system. You've got all these different systems that are listening for the same event. It's very possible that any one of those systems fails to process that event. So capturing that event, making sure that it can be reprocessed, inspected, and so forth, is a hugely important piece of building effective systems, because things can get out of sync if those events aren't processed. So the more you can do to be defensive about that and make sure that you capture that information is just super helpful. Anyways, okay, I think we're pretty much out of time. So I am going to go and try to rest my voice here and see if I can get over this cold. I think I made it almost through the entire winter without getting a cold, but unfortunately it caught me at the end of February here. So anyways, sign up for Ampt. Give it a try. It's very, very easy to use. It's free. You can sign up. You can play around. You can do all kinds of stuff for free. Go to getampt.com. And try it out, check out some of the amazing companies that we've got using it here. Check out the docs and let us know what you think. Appreciate it. We'll see you next week.